Dr. Sadus Khan with you. So in this lecture we will see that what is the effect of the atmospheric things on the link. Generally this is also a thing which is very much debatable because as I have mentioned in some of my videos, basically the data that PathLoss uses is the ITU profiles, and these profiles they were made sometimes back, and not every country updates these values by recording them over a longer period of time. But let's see that because we know that between two stations the microwave is using the natural normal atmosphere as the medium. There is technically there is, we can say, there is no medium, but actually there are layers and layers of medium depending on the temperature and the relative humidity in the area and these kind of other atmospheric things, temperature, pressure, humidity. These are main things. That's why we generally say that a link near to the water body is not very healthy. It's always fragile because the humidity and the temperature and the pressure, they are changing between day and night. So let's see in one of these links. So this is a normal kind of link. I just made this link. This is not a very good link. You see the thermal fit margin is very, very low. The link is not even successful. But we are not looking at the health of the link. We want to see the atmosphere. What is the effect of atmosphere on this link? So for that, we will go to the specular reflections. It's already in variable gradient. Let me first just show it to you in it's saying the path is not line of sight. Okay, no problem. Let's go to the variable gradients ray trace, as this is a place where we can find so let's see that what it gives us. So you see here it is showing us that the waves which are coming out from here, if you see here, there a bit of seems to be tilting down. You see here this wave is coming from here. If it was straight it should be going like that, but it's coming down. Why it is coming down? Because it's basically a very long link. It's a 34-kilometer link. So within 34 kilometers, the earth itself, it bends a lot. So that's why the ray is also bending, because the k value is 1. At the value of 1, it starts bending towards the earth. We will see this in a bit of detail. This is a normal ITU reference of this area refractivity gradient. We can see that the refractivity is changing from 1 and then it's going down. So for most of the time it's from 1, and for 50% or above time it's between minus 50 to 0, or you can say that 1.33 to 1, and then it quite sharply it starts going down. Okay, but this is the ITU which ITU has provided you. But we can see from our side, we can see that okay, what kind of different scenarios that can come over it. Like for example, if I set the M profile, this is using the normal M profile, which has a constant K 1.33. If I just change it, I wanted to see that. For example, I want to see that what should be the value or how it should behave of constant K is equal to 1. So if I make constant K is equal to 1, you can see that this shifted towards right side. So let's see what happens when it shifts towards right side. You see that this bends towards the upper side. So it means that as much as we shift on the right, the bending will be on the upside. And if you see here, I shifted more towards right. Constant K is now 0.5 and dN by dH is 157. So we will see it will. You see, it's now missing this antenna. So when the K value, from here what we learn is that when the K value reaches 0.5, then it will start missing this antenna. If you remember, sorry, I closed it. If you remember this K value is 0.5 is here, almost here. So as per ITU, it will never go in in 0.5 region, but just assume that maybe this is an old reading, and basically now you are hitting 0.5 also sometimes of the day, anytime in the day or in the night. Then if it hits 0.5, then this will miss it. Now let's try to see on the other side what happens. Right now we checked it that if it goes very much out of the normal and it hits k is equal to 0.5 for some time of the day, you will not be receiving anything. Now we take it on the reverse side. Now you see I have put it as k is equal to infinity. At k is equal to infinity, the ray will directly take the earth curvature, so it will bend a bit on the towards the ground. So let's see. You see that the rays are quite much bent now. Much before, very much than before. So the rays are bending down, but still it is not very bad. But let's see how much far it can take. So up to minus 157 it is fine. But if we take it as minus 0.5, like we had taken plus 0.5 and we saw that it misses the antenna. So you see here again, it again misses the antenna. So if we see this curve, so minus 0.5, in it is not shown in the k values here because its dn by dh is minus 471. So we can see that because it is not taking that value as well. It is as per this minus 471 should come somewhere here. This is minus 450. So this should be somewhere here, minus 471. Again, as per this, there is no chance that it will ever reach minus 471. But again, I'm just telling you, I'm just trying to tell you that, some of the links that we saw them on the normal curve and we find that the link should be working fine. It is not showing any kind of issue. But the possible problem is that maybe because of the changing weather phenomena around the world, you are for some time you are hitting the extreme values. So as I showed you that for the extreme values which are not part of this graph, they are out of this graph. One value is almost somewhere here and one value is somewhere here. Both are out of the graph. So as per ITU, it is not possible, or it is not, they have not measured that value in this area, but no one knows. If you are finding some errors, some unexpected errors at some strange point of time, then what you can do is that you have to either, if you have some good arrangement with the weather station of your area, and you can try to get these plots from them, the updated plots, that where this area is heading now. If it has really, if it is really hitting to that places where the value of n is going from to minus 0.5 or to plus 0.5, or it is still in the normal values. Now the other thing is, what is the solution? I gave you a very strange or very difficult type of problem, but what is the solution of it? So assuming that you are really getting any of these things, either for some time of the day your link is bending too much and it's hitting the ground, then from here you can very easily see that, okay, even if it hits the ground at 18 kilometer, if you are somewhere here in 18-kilometer range, then maybe you are still able to get the rays. So this is what we also recommend. If you have an area where you have constant degradation for a longer period of time in the changing weather, generally this kind of scenarios we have seen, they always come when the weather is changing from summer to winter or from winter to summer, because these are the places when the changes in atmosphere are on its peak. So if you're really getting it on some of your link and you are really annoyed, then what you can do is that you can split the link. You can bring one side in between, and that one side, if you see here at 18 kilometer, almost half of it looks very fine because this link is still reaching this place, And if I change it to plus 0.5, you see it's almost kind of reaching this as well. So it means that if you almost make your link as half, then the chances that your link will remain available even if the atmospheric changes are beyond the normal kind of changes, then the chances of this will become very low. The chances of availability of the link will become very high, and the chances of unavailability will drastically decrease even if there's a lot of atmospheric changes. I hope that I have tried to convey my point and you should have got something out of it. If you still have any question or if you did not get any part of it, then do let me know. You can have a kind of you can put your question to me, and if you have some specific site where you want to see that what is going on, then we can even discuss that, and I can make a video on some specific link as well which is having some problem. So see you in some next video. Goodbye.